Hello guys, this is a continuation of our previous lesson on separable differential equation. We are here to solve more examples on that. And today we are looking at these examples. It says solve the following differential equations. Let's look at how we can go about this. So in solving this problem, we were given let's move the whole of this to the other side. So we can see here, over here, that we can factor the x out. So factoring the s, we are going to get y plus 1 dx. Over here too, you can see clearly that when you take the first two terms and factor the s squared out, we are going to get the same thing as what we have over here. So let's factor the s squared out, and here we're going to get y squared plus 1. Over here the common factor is 1, so factor the 1 out, we're going to get y squared plus 1 dy. So here we have this, then this and this can be put together, and that gives us this. This is the same as this, so we're going to get y squared plus 1 dy. So since we have this, it is clear that we can easily separate. So we can just divide both sides by the s squared plus 1 so that we can get the x on that. Then here we can divide both sides by that so that we can get the other side. So when we divide, we're going to get x on x squared plus 1 dx separated. Now over here we have y squared plus 1, divide by that, we're going to get y plus 1 and also dy. So integrating, we're going to get the integral of x on x squared plus 1 dx equals integral of y squared plus 1 on y plus 1 dy. Taking the left hand side, so let me have the integral of x on x squared plus 1 dx. How do we solve this? You can see that u substitution will easily help. So let's say let u equals x squared plus 1, and now the u is going to be 2x dx. So making the dx the subject, you are going to get the x is equal to the u on 2x. Then we put it back into that, you're going to get x on u. Now our dx is the whole of this, so we are going to get the u 2x, and you know that this cancels this, and that gives us integral of 1 on u. While this u, we can factorize that out, and that will give us 1 on 2 u. And you know that integral of 1 on u will give us, so this is half ln of u plus our ln c as usual. But we know that our u is x squared plus 1. Plus substituting, we're going to get ln of x squared plus 1 plus ln of what c. That's the left hand side. So now taking the right hand side, so the right hand side, we saw that we were having, and here you have numerator has a higher degree than that of the denominator, and when it happens that way, polynomial division works better. Y plus 1, and then our this one is going to be y squared plus 0y plus 1. So you know this goes to this y, and that when you multiply, you're going to get y squared. This by that, we're going to get what? Our y. Let's subtract. When you subtract, this will be 0, this will be minus y, then the plus 1. This one will give us minus 1, and when you multiply back, we are going to get minus y, then minus 1, which this will give us 0, and this will give us what? 1 minus 1, that is what? 2. That's what we have. So this is our remainder. So you know that since we have this, now we can break it down as plus the remainder, that's a 2, on the divisor. This is a divisor, that is y plus 1 dy. We can integrate now. We are going to have y minus 1 dy plus 2 on y plus 1 dy. So the integral of that. So when we integrate this, we're going to have y squared minus y plus 2 ln of y plus 1. And because when we try to differentiate this, we're going to get a number which is as the same as the numerator. Okay, then plus our ln c. We are getting half ln x squared plus 1 equals y squared on 2 minus y minus ln y plus 1 squared plus ln c. If you like, you can further simplify this or can choose to leave it this way. So our second problem, let's look at the solution. So we are given dy dx equals y squared minus 1 on x squared minus 1. So over here we need to separate it, and you can see clearly that separating this, we are going to get 1 on x squared minus 1 dx equals 1 on y squared minus 1 dy. Integrating both sides, you are going to get integral of 1 on x squared minus 1 dx equals integral of 1 on y squared minus 1 dy. So you can see clearly that what we have here is the same as what we have here. So if we deal with either the left hand side or right hand side, we are going to get the same solution. Taking the left hand side, the integral of 1 on x squared minus 1 dx. This one, the best approach to use is using the partial fraction to break this one down before we can integrate further. So we are going to get 1 on, so breaking the denominator, we are going to get x plus 1 x minus 1 a on the x plus 1, then plus b on x minus 1. We are getting the a by x minus 1, then plus b by all on what we have there, our LCM, which when we equate the numerator to the numerator we have over here, we are getting 1 and so we can say that when x is equal to 1, we are getting 1 equals 2. So if x is 1, here we can hear all of this go to 0. So we are getting 2 or 2b, which will give us b equals half. Then when x becomes negative 1, we are getting 1 equals negative 2a, which will give us the a to be negative half. So now we have our a and then b. So this implies that our integral of 1 on x squared minus 1 dx has now becomes integral of the a, we had negative half on that of the x plus 1, plus the b, we had half, and on x minus 1 all dx. So over here we can factorize the half out. So when the half comes out, we are now getting 1 on x, there's negative 1 on x plus 1 plus 1 on x minus 1 dx, which we are going to get half. Now we know the integral of this will give us, because of what we have here, when you use the u substitution, we are going to get negative ln x plus 1 plus ln of x minus 1. This implies that it's now, this is the same as that, so we're going to get half bracket negative ln of y plus 1 plus ln of y minus 1 equals the same thing, half negative ln of x plus 1 plus ln of x minus 1 plus ln c. So you can see clearly when we simplify what we have here, we are getting half ln of, so there this will come positive, so y minus 1, then 1 is negative, divide by that, so y plus 1 equals the same thing over here, ln x minus 1 on x plus 1 plus ln c. So when we multiply through by 2, we're getting y minus 1 on y plus 1 equals the c2 will multiply that, and we're getting c on x minus 1 on x plus 1, and that will be our solution for this. And also our last problem says we should solve dy dx equals negative x is on y e power x squared. The initial condition given is that x value is equal to 0 and our y value is equal to what? 1. So it means after solving everything, we are trying to find the constant c after everything. So let's look at that solution. First of all, let's separate by multiplying here by that and here by that, and let's see. So we are going to have y e power x squared dy equals, then this side we are going to get negative x dx. After that, we can see clearly that we can just get rid of this, and that give us y dy equals negative x on e power x squared dx. And since this exponential function, you can move it up, and that will give us y dy equals negative x e power negative x squared dx. So now let's integrate. Integral of y dy is equal to negative integral of x e power negative x squared dx. And over here, we know clearly that we are getting half y squared, and over here we can use the u substitution method and it will work, in the sense that if you make the negative x squared become u, then we simplify, the x will come and cancel this x. So let's take that side. Well, first of all, let me write this. So we're taking let our u be negative x squared. Our du is equal to negative 2x dx. Finding the dx, we are getting negative 1 on 2x. So let's substitute back and see. Substituting back, we're going to get negative integral of x e power, the whole of this is u, so here becomes u. Then our dx, this is now minus 1 on 2x du. So if that's the case, this cancel that, we're going to get integral of x e power u dot half x du. This cancel that, then our e power u, so I can bring the 2 out, du, which if I integrate, I'm going to get e power u, then plus c, but my u is negative x squared, so that means we are getting half e power negative x squared plus c. So now the whole of this now becomes half y squared equals half e power negative x squared plus c. But we shouldn't forget that we are given x to be 0 and then y to be 1. So let's substitute that back into it. So we are going to have half, because when you put 1 there, it will be the same thing, because then this 0, the whole of this goes to this, the whole of this will be 0, then e power 0 is 1. So this is also going to have plus c, and that will give us c equal to what? 0. So now that we have the c, we can say that our equation is half y squared equals half e power negative x squared, which we can multiply through by 2, and that will give us y squared equals e power negative x squared, and that our y will be plus or minus e power negative x squared, which can also be written as e power negative x squared by half, and that is also e power negative half x squared. And I think that is the answer. Please try to share, subscribe, and like.